Welcome everybody to one of our lunchtime webinar series through the Circular Economy Hub as part of the NICER program. So if you've been on one of these before, it's a sort of a stimulus event to bring a topic that's been suggested to us by the community. And for this month, the topic is on data, artificial intelligence in the circular economy. And we've invited two speakers. Some of you will know Fiona. Charlie will introduce herself in a minute. She's co-director of the Circular Economy Hub and working in this area on a number of fronts. And then we've also invited Hamid. I think he's in Germany, can't remember exactly, but we'll come to him in about 15 minutes. So we'll run both speakers back to back, post your questions, and we'll then sort of have a Q&A and a discussion for the latter part of the session. So Fiona, is that okay for you to come in and kick us off?
Yeah, that's great. Thank you. Good to see you all. So I'm, as Peter said, Fiona Charnley. I'm a Professor of Circular Innovation at the University of Exeter in the Business School, and alongside Peter, Co-Director of the Circular Economy Hub, which is part of the NICER programme. And today I'm going to give you a bit of an overview of the role of digital economy broadly and data, and how it can enable our transition towards a circular economy. And I'm going to draw on some findings from a recent report that came from a study that we did into the future of digital technology.
Oh, really? That must be annoying. I don't have any headphones.
So I will just share my screen. There we go, should be able to see the full screen there. Great, okay, so just thinking really about digital trends and the opportunity that it presents for the circular economy. I mean, the potential for digital technologies to reduce carbon emissions in manufacturing in particular is significant. And we have many existing tools such as the Industrial Internet of Things, machine learning, AI, and smart sensors that monitor component performance, for example, and the condition of components and materials and products to predict lifetimes and value. And in a recent report that was launched by the Royal Society, it's estimated that these types of digital technologies can contribute almost 1/3 to the required reduction of CO2 by 2030, which is quite significant. So high value manufacturing is one area that digital technology has seen the most significant gains, with billions of sensors already being used in areas such as transport, manufacturing and engineering to bring about transformational innovation in the products that we use and the processes that we use to develop them. So if we take Rolls-Royce, for example, Rolls-Royce have long been using sensors across their 4,500 strong fleet of engines, and they collect vast amounts of data about engine temperature, fuel flow, airflow, and pressure. And they analyse that data to identify maintenance problems before they actually emerge. And they also use that data to economise their fuel use and also their flying patterns. If we take wind farms as another example, wind farms use remote sensing to detect everything from weather conditions through to blade vibrations, and they use data to prolong the use of wind turbines while in use. And as connectivity has increased, driven by the ubiquity of wireless networks, the maturity of mobile networks, and readily available big data, and also the falling costs of monitoring and analysing through these types of technology, more and more businesses are realising the opportunities presented by these technologies. And another report recently produced by McKinsey estimates that around 25% of businesses are now using these types of technologies, and that they are actually forming a core part of the digital revolution, sometimes referred to as Industry 4.0. And that's really blurring the lines between physical, digital, and also biological spheres. And the report by McKinsey also suggests that the biggest gains are yet to come, and particularly in the area of the circular economy, which is an area of significant growth. However, whilst the development and innovation around the use of digital technology is racing ahead, we need to be really careful that we are not only making more complex and multi-layered products with embedded technology at a faster pace than ever before, but we need to be careful that we're not making these complex products that are impossible to disassemble, to reuse, and to recycle. So we need to be sure that we're creating a technology-enabled system of the future rather than a technology-driven. And so one area where digital technologies and the smart use of data can have a significant impact is through the support and enhancement and acceleration of a circular economy. And through regenerating the natural world, reducing the need for virgin materials, and reusing and recovering resources to avoid waste, a circular economy represents a critical pathway to achieving net zero in manufacturing and beyond. And one of the most important things about the circular economy framework is feedback. So you're not going to know if something is circular unless you have feedback to evaluate its potential and to evaluate its progress. And many of the cycles that we see within a circular economy are heavily reliant on this feedback. You know, circular economy is an inherently feedback-rich system by design. And much of this feedback is made possible through the digital technology that we've just spoken about. So if we think about the three key principles of a circular economy, first of all, to eliminate waste and pollution, secondly, to circulate materials at their highest value for as long as possible, and then thirdly, to regenerate nature. We're already seeing where advances in digital technology and the use of data and AI are enabling and accelerating the adoption of these principles. So if we think about designing out waste, for example, 3D printing and agile manufacturing combined with the Internet of Things technology are eliminating the need for storage and large storage inventories of spare parts in physical warehouses, for example. So sensors in vehicles can be used to detect faulty parts in real time and prepare a replacement by accessing a virtual inventory of files, printing parts on demand in a nearby location, ready for engineers to install. And by only producing parts that are needed, obviously has many material benefits, but there's also many positive secondary implications too. So for example, with the right equipment being in place, an aeroplane with a fault can be repaired on landing, no matter where it is across the world, rather than having to wait sometimes many days for the replacement part to be tooled and manufactured and then shipped to the right location. And so this means that the service can be operated with fewer vehicles and in the example of a plane, be kept in the air for as long as possible. Digital technology is also being used to extend the lifetime of products through disassembly, remanufacture, and then reassembly and distribution. So smart warehouses, for example, are already equipped with autonomous robot pickers, wearable devices for warehouse operatives, and RFID tags. And this technology is kind of meshed together using the Internet of Things to make the flow of goods both into the warehouse and out again as fast and efficient as possible. And technology is now being developed to focus on the reverse flow of materials and products. So we're now seeing developments in technology where robots can automatically sort and evaluate and assess and prepare a product for remanufacture. Machinery that can extract valuable parts for reuse and also separate different products and parts into recycling streams. An example is Intel are now able to actually reuse or reclaim 99% of their returns using this type of smart technology. And then finally, if we think about regenerating nature, this can also be enabled through digital technology. For example, circular business models that increase utilisation of cotton clothing. For example, in H&M, they're using IoT-enabled clothing rental and swapping services, and this could reduce demand overall for cotton. Another example in land use is where grazing technology from a Norwegian company called No Fence means that livestock can actually be restricted to certain areas using geographical rather than physical fences set on a smartphone app that communicates with a solar-powered collar on each animal, which emits an audio warning when they stray out of a zone. So loads of really interesting advances in technology that are being used to implement circular economy principles. So I now want to go on to share some of the findings with you from a study that we've recently completed, which looks at the challenges, opportunities, the challenges and opportunities facing digital manufacturing over the next 10, 20 and 30 years. So this study was undertaken in collaboration with the Connected Everything Network, which is an EPSRC-funded research network for the digital manufacturing community. And it was a horizon scanning study, which included a review of the academic, industrial and policy landscape, so all of the relevant documents coming out of that landscape. We also undertook quite an extensive survey of manufacturers, and we hosted a series of roundtable workshops with experts from across academia, industry and government. And essentially, the study explored current and future manufacturing challenges, current and future use of digital technologies, and what a vision for 2050 could look like in a digitally enabled world. And the findings from this study were clustered into 4 key themes, as you can see here. So industrial digital technologies in 2050, digital support for achieving net zero, digitization and the manufacturing workforce of the future, and then digitally enabled manufacturing resilience. And there was quite a few findings that overlap between these 4 themes, but I'm going to focus now on what the findings were around how digital technology can enable net zero manufacturing. But the report is available to download. I've included a link on this slide. So what we found when looking at current and future drivers of new net zero enabled digital manufacturing, the study found competitive advantage to be a key driver, both in job seekers and also potential investors actively seeking companies with convincing net zero strategies, and also those companies that were innovating in the digital technology space. Existing and future legislation to reduce tier 1, 2 and 3 emissions and consider the whole life cycle of products through the right to repair, for example, and extended producer responsibility were also seen as key drivers of change. As expected, there were quite a lot of barriers to the adoption of digital technology to advance net zero manufacturing, and some of these barriers included a lack of knowledge concerning the measurement of emissions and how to reduce them, and also a lack of consideration of end of life or waste management in the design phase, and also the logistical complexity of enabling stakeholders from across the value chain to work together on the introduction of new alternative models of production and reducing emissions was seen as quite a challenging barrier. The use and availability of data came up. Yes.
Yeah. Just getting somebody who's got their mic open, having a conversation. If people could just keep their mics off while we're presenting, that would be appreciated. Thanks.
Okay. The use and availability of data also came up in our study time and time again as a key barrier to progress, and this included the lack of motivation for companies to collect and share emissions data, and also a lack of available data to enable the transparency that we need across the supply chain, and also a lack of standardization to enable that sharing of data, and the lack of understanding around what data is actually useful to drive and evaluate change. So then moving on to kind of what digital technology was found to be available to support net zero manufacturers and manufacturing. All stakeholders that we consulted during the study agreed that there's a significant potential for digital technology to support the reduction of carbon emissions and the transition towards a circular economy. Digital technologies could make energy systems and value chains more connected, for example, more intelligent, efficient and transparent supply chains and value chains, which obviously would be a key enabler of a digital economy. The use of digital twins came up as a particularly valuable tool to explore alternative scenarios and the impact of interventions that we could make to reduce emissions. And also design was seen as a crucial element to the development of next generation products. However, it was felt that designers need to use data-driven approaches to make decisions, particularly over multiple use phases of a product, obviously where that data is available. And then finally, just some of the key recommendations that came out of the report. First of all, connecting digital technology developers to manufacturers was seen as a key enabler for digital solutions to land in the sector and to truly contribute to its development. There was also seen the need to reduce digital manufacturing knowledge barriers. So if manufacturing is to become smarter and more agile, it's really important that new tools and solutions are introduced to enable manufacturers to really understand how to use these digital technologies and the data. Thirdly, consolidating digital manufacturing guidance. So the internet is obviously a powerful source of information, but the knowledge landscape can be quite fragmented. And the best sources can be difficult to identify. So there's a real need to pull this together and target it towards manufacturers. Supporting employee well-being during the transition was also seen as key. And then finally, promoting transparency across the value chain. So what tools can we use? What data have we got access to? What's missing? And how can we standardize some of this data so that it can be accessed in a valuable way? And then just finally, I wanted to draw some attention to some of the work that we're doing in the Circular Economy Hub. So as most of you know, the Hub is part of the NICER programme, which is a £30 million UKRI investment to accelerate our transition towards a circular economy in the UK. We have 5 centres working on different resource flows. And one of the common themes across the programme is data. And so within the Hub, we're developing a National Circular Economy Data Observatory. And the purpose of this is to integrate data to deliver policy and industrial insights. We're developing a taxonomy of signature case products, components and materials to demonstrate how this would work, and also developing a dashboard to visualise and explore potential, explore data within the context of future circular economy policy scenarios. Within the Hub, we've also developed a circular economy knowledge platform, which hosts lots of different case studies, interviews with practitioners, and reports that highlight different knowledge that's coming out of the circular economy community. So that might be a useful resource for those of you who are interested in this topic. So I'll finish there. I've added a couple of links, first of all, where you can download the report that I've just been talking about, and also a link to the Knowledge Hub. Thank you.
Great, thanks Fiona, and well done for battling past some of the background noise. So somebody on the call has got their mic open or is picking up background noise. If you could just double check. I can't see anybody obvious in the chat or the participant list, but if you could just check so that we can then sort of run through smoothly. So Fiona, I'm going to move on swiftly. That's a fantastic coverage then of a huge set of data and technology related topics that I'm sure will be relatable to many people on the call. And one of your slides, I think, sort of showed particular applications related to eliminating waste and pollution, circulating materials and products at their highest value. And I think we're going to go into a bit of a deep dive now with Hamid, who's going to tell us a little bit about his work. So Hamid is the lead data scientist at Circunomics. I think I often trip up over that title, so correct me if I've got that wrong. Bachelor of Science in Energy, Master of Engineering in Chemical Process Engineering, Computational Energy, PhD in inverse problem model training and parameterization. I barely understand some of the words. So Hamid, I know you're going to give a very, very good example of the application of some of the things that Fiona's been talking about to a topic that will be very familiar to a lot of people. So over to you. And again, I know we had a bit of background feedback on your mic earlier, so let's hope that holds up, and I'll only come back in if we need to sort of make any adjustments. So over to you, Hamid.
I don't know if you have some noise now, but yeah, I have my mic is open. Do you hear me?
Yeah, that's okay. Just about okay.
Okay.
A little bit of echo, but let's go with that. If you want to share your screen as well.
Okay. Yeah. Just that.
Great.
Yes. Okay. So let's start. I will repeat my introduction. I have my presentation. So hello, I'm Hamid Bedri. So lead data scientist at Circonomics. It's in Germany, and I'm working there since 2021. And as mentioned before, I have a background in computational engineering and energy, in addition to a PhD in inverse problem. And by inverse problem is model parameterization and calibration and training. So I have several working experiences as a scientist and data scientist in different domains, starting from natural science, physics, logistics, pharma, and battery modeling. And I'm leading the CX analytics, modeling, data engineering, and software development at Circonomics. And today I will present you Circonomics, its vision, and a view on how AI helps us in CX analytics. As mentioned here, Circonomics is the one-stop solution to manage the complex battery life cycle at scale: battery performance prediction, asset management, remarketing, and recycling in one solution. So this is the plan of the presentation. We start with a short introduction about the team and Circonomics. Then I will show you a snapshot of AI and modeling work done at Circonomics. And after that, we have the conclusion and the discussion. So we have more than 15 talents and of 10 nationalities in Circonomics. And Felix Wagner is our CEO, and Jan Born is our CTO. And on the right are part of the engineers that are mainly working on the analytics. So Circonomics is based on two main components: the analytics for first life and second life simulation, and the marketplace for trading batteries into a second life and recycling. Managing the take back with foresight and transferring them into afterlife can be complex, especially for large volumes. So Circonomics helps battery owners in predictive planning and decision making regarding the second life suitability. And in the next slide, we will jump directly to the modeling and how we detect anomalies. So we are using an AI, and by this I mean tools that work with less possible hard-coded rules. So we use an artificial intelligence model of type autoencoder to detect anomalies. And I will explain it to you using the example of dogs. So we train dogs to detect certain abnormal substances, showing them those same substances. However, for the autoencoder to detect anomalies, we train them using normal data, because it's the most abundant data. So the ultimate goal of the autoencoder is to reproduce the input that they were given and compute a score based on the input and the output. And I will explain you that just after a moment. So we make them in somehow overfit to the normal data. Then when they are fed with the anomalous data, they fail in reproducing it because they overfit to the normal data. And thus the score that is nothing but the aggregation between the difference between the inputs and the outputs is high. And we'll see it just after in an example. So to see it in another view, so let's imagine this is the autoencoder. So we feed it with a picture of 2, handwritten digit of 2, and then the autoencoder will generate this number, but it's different. So it's another picture that was generated by the autoencoder. So when the picture generated by the autoencoder is different than the picture that it was fed with, then this is an anomaly. So for example, if we fed it with the letter A, it will fail to reproduce the letter A because it was trained on numbers. So let's focus now on the bottom part of this slide, where we see an example of anomaly detection performed on rack minimum temperature. So the minimum temperature in a module in a battery, using an autoencoder, the deep learning architecture. So the model is designed to get as input the data of the last hour with a granularity of 10 minutes, and gives as output a score for allowing to decide whether there was an anomaly in the last hour or not. So we feed it with the data in black, through the data, and then the model will reconstruct this data, the same data, in green, not in green, in blue. So you can see the score here, which is the difference between the input and the output. When the data was normal, the score on the bottom was low. However, when there was a sudden drop in the temperature here in black, so the model didn't succeed in reconstructing perfectly this sudden drop, so it reconstructed this blue curve, and the difference is high, so we detect an anomaly because now the score is high. And this is a snapshot from CX Analytics app pointing in the anomaly detection components. Yeah. So for this example, we can see how CX model is used to predict the state of health of batteries from battery management system data, the BMS data. It is a regression problem where we use CX model that maps the current voltages, state of charges to the SOH. So we feed it with the voltage, current, and SOCs, and the model will predict the SOH. And in this slide, we can see CX battery lib simulator. It is also used in the marketplace to augment the seller offer with respect to the buyer. So in fact, you can build your own battery pack module or just use the cell model to test custom loads, custom load profiles at different state of health, using different conditions, contact resistances, and different configuration. So this gives an overview on the performance of the batteries sold in CX platform before the buyers can buy. So they have a taste before they buy the batteries, they can see how they behave in different state of health. And by what I mean with state of health is the age of the battery. So you can test even old batteries and see how they will behave. And this is an example of the simulation produced by CX model to show the quality of the prediction and how we separate data for training, validation, and testing. So we train the data using this chunk of data, and then we validate it with the whole data here. And then for testing, we use field data. So like you see here, the fitting of the data, the true values versus the simulated one. And here is an example of simulation produced by CX Pack simulator model. This is a heterogeneous module simulation, exactly for P1S. And by this, I mean 4 parallel cells in a module. So you can see, because the module is heterogeneous and the cells are not the same, so the state of charge is not behaving the same way. The voltage is the same because there are 4 parallel cells, and the current of the module is the big one here, big values. And the current that is flowing in all the cells is the smallest value. And we are near finished, and here is an example of a pipeline scheduled every week that predicts the state of health. To do so, we are using Apache Airflow. It's an open source software on a Kubernetes cluster to allow us to scale seamlessly in case we need to execute multiple pipeline of multiple battery packs. And here, every row is a task, every column is a week, and a green square represents a task successfully executed, and a pink the ones that were skipped, for example, in case of missing data. On the bottom, we can see the pipeline that were executed every week. So we pull the data, process it, select the healthy sample, predict the state of health, upload the results, and we clean the results. So now we are in the conclusion. We have seen brief introduction of what we are doing at Circonomics and how AI helps us in achieving our goals, how we are detecting anomalies using AI, prediction of battery state of health, CX battery pack simulator, and what we didn't see in detail, but CX Analytics provides, a custom dashboard for CX clients, automatic infrastructure and code deployment running on Kubernetes cluster for seamless, efficient, scalable solutions. And we offer also adapted AI and models to augment the experience of the customers of Second. And yeah, thank you for your attention.
Okay, great, Hamid. Extremely interesting. Very, very specialized, but links extremely well to what Fiona was describing as about application and future potential. So I've got some questions that I'm interested in, but I'm going to encourage people to post their questions first. There was a question that came in from Fiona to start with, from Hadi. Are you there, Hadi?
I'm still here.
Great.
Hi. Do you want me to repeat the question then, Peter? Sorry.
Yeah. If you could read it out, that's much better than me reading
Thank
it.
you very much, Fiona. It was really interesting. Basically, you went through the recommendations at the slide before the end, and you highlighted like 5. The third one was essentially there is a need for consolidation of all the efforts and necessarily the knowledge that is around the circular economy. Okay, my question is, whose responsibility is that? And the reason asking that question, I come from the built environment area and construction in general, and the built environment in particular. We have a really bad record in terms of circular economy. There is a huge amount of research going on in terms of how we can improve it. And now, particularly with the buzzword of AI, how AI can essentially help us to work. So thank you, Hamid. Essentially, I'll ask another question in terms of the potential for basically cross-sector learning. But Fiona, whose responsibility is this? Is it government that should facilitate that one? Is it the businesses themselves? Is it within the sector? Because it does have some cost elements, essentially cost implications, let me say. So depending on who is responsible for this one, it could change the view of the companies that are active in that field. Apologies, it was too long, Peter.
That's so clear, Hadi, and we'll ask Hamid also to come in on that question and ask whether the application that he's talked about is transferable or potentially transferable. But Fiona, do you want to have a go at that?
Yeah, sure. Thanks, Hadi. So it's a really good question and not a straightforward answer, but I think it's the responsibility of kind of several different stakeholders. So I know that government, particularly the Net Zero Research and Innovation Board, and then also DESNZ's Department for Energy Security and Net Zero, are currently creating a net zero strategy in response to the Skidmore report that recently called for the need to produce a technology roadmap. So how technology can be integrated, how we can share the learning, particularly looking at a transition towards net zero and a circular economy. So some of that work is being done, and as the hub, we're feeding into that in terms of kind of what the academic research and capability is that we can offer in this area. But of course, you know, it's a really complex landscape, and as you mentioned, the built environment, there are different technologies that are being developed by different sectors and looking at particular resource flows. So within the NICER programme, as you saw on one of my slides, we have 5 individual centres as they're specialising in particular areas. So we have one on the built environment. They are doing some of the work to pull together that learning and that technological advancement. So we're seeing more cases of where academic bodies and programmes are taking some of that responsibility. But as you said, it's not the responsibility of just one player, and it's quite a complex challenge. But we are starting to see some of that work and that mapping being done.
Great. Hamid, did you want to come back, and then back to you, Hadi, to see whether you're happy with Fiona's answer? So Hamid, transferability. Could you do it? Could you do what you do for batteries in another sector?
It depends. What, like, for example, if you may give me an example. Yeah.
I think what I was, apologies, Peter, can I come in?
Yeah.
Sorry, what I was looking for essentially, it's great, but it's, I don't want to say basic, but it's a very fundamental model that essentially trying to detect anomalies. In other sectors, it might not be just detecting anomalies, but rather than that, making a pattern of a successful application. So because you've used this one, and as I said, AI in construction, although it's been around for a long time, but it's still in an infancy, essentially. We're just trying to learn how AI could be used in construction. Compared to manufacturing, we're way behind in terms of technological advancement. So I think there's transferability, but based on what was done in the manufacturing sector, do you think the same principles could be applied to the construction world in a sense that we build buildings? Okay, so rather automation in the process, can we use that AI experience of manufacturing to automate the processes within other sectors?
I would say in the construction sector, for example, for efficiency of the construction, supervising the energy consumption, optimizing it, detecting if there is some leaks of heats, for example, those all can be applicable to the construction sector. So.
Perfect. What about the human aspect, Hamid? Apologies to interrupt. Because right now we're working on an AI, conversational AI tool like ChatGPT to enhance the human perception of health and safety while working on site. So do you think the similar tools could be developed that link it to the circular economy, essentially? So the human perception, human work. Could it be controlled or improved in terms of performance using AI?
Yes, if you go to this computer vision field of AI, where you will supervise the video channel, so to enhance the security, I mean. And there you can use models to detect if there is something hazardous happening in the field while the people are working or not. Yeah. This field is applicable, really applicable. Yeah.
Thank you both.
So, Hadi, are you involved in the NICER program?
No, I'm not, to be honest, unfortunately.
Okay. Yeah, I mean, there's some interesting work. If you look at something like the National Infrastructure Commission, their work on AI and data and looking at what Fiona was talking about, these prognostics, and looking at repair and maintenance and pattern spotting in structures is growing. But as you say, it's still early days. But I just wondered, there are several projects in NICER which are not construction, but they're using what you've just described, Hamid, as visual techniques to look for pattern spotting in end-of-life materials to be able to improve segregation and for example, metal scrap or different alloys. So that's work that's ongoing in some of the centres. I've just got a question I wanted to ask Hamid about the commercial dimensions of this. Is who are the customers? Are you dealing with the battery manufacturers or the vehicle manufacturers or the end-of-life vehicle decommissioning scrappage companies, or all of them? Who's got an interest in looking for these anomalies, and what happens to batteries that have an anomaly? What happens to them in Fiona's butterfly diagram? Where do they go once you've spotted an anomaly?
So to answer that question, so who is interested in this anomaly detection problematic is the energy storage system, for example, energy storage system providers.
Okay.
And so when you have a fleet of packs that are deployed to provide energy, you want to know when there is an anomaly happening in some pack. So, and at that moment, you have to send the personnel to check and do the maintenance and see if effectively there is an anomaly or not. And if there is, they should like either replace it or they will contact the insurance to see what's happened and if they can be recovered from get a refund or something like this. And to avoid the hazard. And this also can be applicable also to OEMs and cars. So the only condition that is needed is to have the data. So save the data and then you can do it.
Yeah, and I mean, I hear a figure quoted often, Hamid, that 80% of the effort and time in AI is cleaning the data, what you call the input data, and it's higher in some applications than others. Is that your experience, or do you have a very sort of easy sort of job in terms of the data that comes to you is very precise at the outset and is well controlled?
The data that is coming to us is, I will not say easy because it's numerical values. It's not language. It's somehow structured. What's missing in the data? What's the problem with the data is the missing values. So sometimes you have some disconnection in the network, so you have missing data. So yeah, that's the like big problem that we have here.
Oh, that might be.
And one thing also with the batteries, they have some inertia. So the feedback that you have to have is not that like the fast. So if there is, for example, the degradation of the state of health of a battery, the state of health of the battery will not change like in seconds. So it's a matter of I don't know, hours, days. That's like the pattern will build up and the degradation curve will build up and the trend will start to appear. So there is some inertia, but sometimes there are some big accidents and then some big hazard and then like the sudden drop of the temperature. But this is just a sudden drop of the temperature caused with okay. External factors, not internal factors of the battery. So it's not. That's important here. So okay. I'm just giving examples of.
Yeah. So it's not straightforward. I saw that Chip has come on with a question. Chip, do you want to come and ask your question, which is to Hamid, but I think it could also be picked up by Fiona.
Hi. Yeah. Actually, yeah. So my question is, it sounds like you have a very data-rich environment with these battery packs, where the data is very clean. It's coming out numerically, and I think compared to a lot of the circular economy data streams, as Peter said, the data could be very dirty or just non-existent or unstructured. So, but I guess my question for you is, in the case for batteries, could this data be used somehow to inform the repair or reuse of some of the cells in the battery pack? So I imagine if you notice an anomaly, perhaps the data pack or the battery pack could be remanufactured or portions of it could be reused. Is that feasible? I mean, that might extend the life of just the use of the battery cells, right? For more of a circular kind of economy around battery reuse.
I would say yes, and it depends on the granularity of the information that you are getting from the module or the pack. For example, if you have a module and you have the information at the level of each cell, so we have, for example, the voltage of each cell, the current temperature of each cell. At that moment, you have the ability to say, yes, I can replace this cell or this cell. But would it be possible to like unlock the module and dismantle it and replace just that cell? In the reality, in the real life, it's not that applicable. If you take, for example, a module of Tesla, the cells are there, you can replace them theoretically, but practically you cannot because they are glued. So this is one of the problems that you can have. But definitely you can replace the module because the pack is composed of modules. If there is like an anomaly in the module, you can replace the module inside the pack. But I think somehow it will be easier.
And Fiona, more broadly then about some of the examples you gave, or the big picture do you see some of these technologies being able to impact on the upstream sort of design of products and get that feedback loop?
Yeah, definitely. We're definitely seeing how people are designing, companies are designing products differently based on the data that they're receiving from product use, for example, or certainly end of life. One of the other examples I wanted to give, a few years ago now, we did some work with a network of remanufacturers, and with remanufacturing, one of the biggest challenges is that you don't know the quality of the core that's coming in. You don't know the quantity of cores that you're going to receive. However, lots of the products that we're seeing now have, connectivity technology, they're collecting data. And so we simulated an example of where smart products were coming to remanufacture, and we actually simulated the environment so that if remanufacturers were to have a higher certainty of the product quality, even if that product was low quality or high quality, it would actually reduce the time to evaluate that product by 2/3, significantly reducing the time to remanufacture. So it's an example of how getting the right data to the right people within the value chain can significantly enhance kind of that process, or indeed can open up opportunities for completely different models as we're seeing.
Right. Okay. Khalid's been waiting patiently. I think his question is Hamid, and but again, Fiona, if you wanted to sort of respond to it or not, then dive in. But Khalid, are you there?
Yes, Peter, I'm here.
Yeah. Okay.
Thank you. So yeah, this is more of a technical question to Hamid. You did, of course, Peter highlighted one of the main sort of the banes, if you like, of analysts' existence, which is data conflation, cleaning, and all of that. But in your world, thankfully, it's not a significant issue. But you also mentioned your problem is with missing values, and that which is also a common problem. And then I know there are different techniques depending on the data type or the structure. So in your world, how do you handle missing values? If you can share that, that'd be great. Thank you.
This question is a little bit technical and depends on the case and the feature that you want to fill. For example, if you have a missing value, and it depends on also the quantity of missing data. For example, let's say you have 1 hour of the data and you have, I don't know, 5 seconds missing. You can fill it, like you can interpolate it, for example, with mean values. For example, for the temperature, you can take the mean value of the temperature and then put it there, or do some linear regression in the missing value. But if there is, it depends on the application and the model that you are using. If there is too much information that is missing, you can't make a decision at that moment. What you can say, you can raise a warning and say, there is missing data here, you have to check. That's all I can like.
Right, because
and the model should handle the missing data, even if you interpolate it using mean value or linear regression, just to fill the data, to feed it to another like more important model like the one that we are using here, the autoencoder one. It should be robust enough to handle even and understand that you interpolated the data and fill it, and should not give wrong results with interpolated filled data that you pre-processed before. So it should be robust.
Excellent. So just, I mean, what I probably would want more clarification on is where you have multiple missing values. Say, for example, because in your model, you would have several features, right? So if you're going to take the mean value, for example, of the missing feature, so I'm assuming that would be the mean value of the affected feature, not all of the features, right? And also where you have multiple missing values, but then in your case, I'm assuming you'd also normalize all the features before running the model. So with the normalized and multiple, how do you then account for the differences that, because with the original features would be of different scales and all of that. So would that be taken care of within the normalized data sets, or do you have to reverse the whole thing and then go back again?
The normal process is like you take the data, you detect the missing value, you fill them, then you normalize, then you feed them to the model.
Okay.
Oh,
I
you've
think
gone
you're muted. Oh, you're muted.
mute, Hamid. Yeah.
Okay, sorry. So the normal way of doing the thing is like you take the data, you detect the missing values,
Yeah.
you fill them if they respect the condition that you have. So you fill at a certain number of the size of the filling, it should be constrained, not like to fill, if you constrain it to 5 values, for example, not 10 values. And then after that, you do the normalization.
Okay.
And after that, you feed it to the model. And after that, you rescale to the, because the result may be scaled and normalized, you have to rescale back to the normal.
Okay.
Yeah.
Okay.
And then you, yeah.
Let's
Okay,
hold
so
that.
that's really good.
Let's hold
That's
that there and form a special interest group after the event for those who want to get into that. I've got a question that's sort of broad but also specific, and it's about product passports. So we hear a lot of talk about the global battery passport and product passports generally. So it relates to a little bit to Chip's earlier question about, okay, how do we use all this to move towards circularity at scale? So my question to Hamid is where does your work sit into that sort of idea of a battery passport? Does this sit outside it? Is it integral? Can it really sort of help drive, that sort of passport idea? And the same question to Fiona in the bigger picture is same question, but where does all this data, the digital, all these tools, does it help us move towards passports? Are passports a good thing in general for circularity, et cetera, et cetera? So Hamid, do you want to start and just say where does your work sit in the the battery passport movement?
It's a very important point here, the battery passports, and we are participating in that, in making it real. So in our marketplace, you have batteries that you can buy, and normally you can buy batteries otherwhere than our marketplace. But our marketplace is kind of offering that battery passport by not just offering the hardware, the batteries, but the data of the batteries. So you have more transparency of what you are buying. And in addition to that, we are giving kind of digital twin of the battery that you are buying or the module that you are buying. So you can build it yourself with the model that we are building. You can combine the cells at different state of health in like kind of more realistic way and test it before you buy it. So it's different like if you go to eBay and you find just a module that is there and no information about it, about the state of health, about how it will degrade, about characteristic of the module or the battery that you are buying, like internal resistances. We at Circonomics, not just we are like providing a data sheet, we are providing a model of the battery that you want to buy. So you can test it before you buy it. And I agree with the battery passport, it should be there. And like the OEM that want to put their batteries in second life, they should put more information and provide more information to the potential buyer.
Okay. So it's probably another 1 hour webinar on its own. But Fiona, last thoughts before we have to close on passports in the work that you're doing.
Yeah, I mean, I think the concept of a materials or a product passport is fantastic and would provide lots of different benefits for the circular economy in particular, across the value chain. I think one of the biggest challenges is the interoperability and the sharing of data and who is creating the passport. What we don't want is individual companies creating their own versions of passports that are only for internal use. We want this data to be made widely available, and therefore I guess the question is, whose responsibility is it to create, and can we break down some of these walls around sharing data between different organizations, between government and business, public and private.
Great. That might be a topic for the future. We're coming up to 1 o'clock, might already be there. We've done well. We've never mentioned blockchain. We haven't mentioned Bayesian statistics. That's always good for a lunchtime webinar, but we had quite a detailed discussion about the specifics around batteries and particular applications, which I really enjoyed. I don't know whether your slides are shareable, Hamid, or a version of that. That would be great. And Fiona, thank you for setting the big picture and giving us a bit of a dive into some of the work that you've been doing and are doing through NICER and other projects. So thanks everyone for your attention and participation. So that's great. And there'll be 2 more webinars, I think, to be run before we break for the summer. Those will be circulated in due course. So thanks, digital round of applause to Hamid and Fiona. We gave them a tough brief and did a fantastic job. So thanks everyone. Enjoy the rest of the day, evening, morning, wherever you are, and stay in touch with us and follow up with any questions or reflections or observations after the event. That would be much appreciated.